Sam is making his triumphant return.
Yes, after eating bad cranberry juice.
How are you feeling today, Sam? A little bit better?
Feeling excellent. I think we're gonna crush it today. We'll
Yeah.
be done by 9:05 with both problems, and I can get to bed.
Sweet.
How does that sound for everyone? Or
That-
that is midnight 05 for you guys on the East Coast time zone.
Yeah, that sounds great for me. I think that's 2:05 for someone in UTC +8, I think. Though I know we have some fact checkers who can let us know that.
I think it's 1 p.m. actually in UTC.
Oh,
+8.
1 p.m. Okay.
Yeah.
Let's see. Time in UTC +8.
Hello.
Oh yeah, it's gonna be
Good evening,
almost
Harry.
1. Yeah.
I hope things are well in UTC +8.
I said yesterday at the start of the stream, Sam, I don't think you were there, but I said I was hoping for a short problem because the day before was really short, and which I think was bit masks. And yesterday's problem ended up being pretty short. It took me about 80 minutes. So today I'm hoping for pretty short as well. But
So pretty short is like
see.
under an hour and a half in your mind?
pretty short would really probably be under an hour at this point, I think. But
Oh my gosh, my computer is being a very silly Billy.
yeah.
Yeah, I'm having some network connectivity problems.
Oh, that's not fun.
But you can see me.
I can
just
see
can't
you.
send the email that I forgot to send 2
Okay.
days ago.
Sam sends his email on stream is my favorite segment of Advent of Code.
Well, it's the same email I'm trying to send. I just realized I forgot to send it because I got distracted
Oh
by
my
AOC.
god, Sam.
So it's only one email that
Good
I've ever
stuff.
sent on stream. It just still hasn't gone. Now it's giving me all sorts of errors. But it's my favorite segment as well.
Nice.
AOC is about to start.
We still got
AOC.
2 minutes and 20 seconds.
AOC more like
I was gonna say
AOC.
something.
I don't think Harry knows what AOC is.
I was gonna say something, but I forget. Now you're distracting me. Oh yeah, as we've learned, me parsing strings in Rust is pretty slow. I think I was faster yesterday. I learned some tricks to parse things a little bit faster, but still, me parsing strings in Rust tends to be pretty slow. So if the input is short, then that means that the problem overall will go faster.
Mm-hmm.
Hey William, I am using Rust. This is... You've done Advent of Code before, right?
Who is William? Is William
William
Oberlin?
is my friend at Oberlin College. He's a computer science major. We declared our majors on the same day.
Oh my gosh, how cute.
He is in Pennsylvania. Maybe I shouldn't give all of his personal information
Yeah,
out
don't
on
give
stream.
all his-
1 minute left.
I think you've given him away enough of his info at this point. Message sent. Perfect.
Nice, you
In
sent
time
your
for
email
AOC.
with 50 seconds left to go before the problem drops. So William, just to
Drop
fill
that
you
problem.
in, I'm trying to solve these kind of reasonably as quickly as I can in Rust. If I were going for actually as quickly as I can, I would do it in Python. But something that Sam and I did before and that we're probably going to do again is we'll read the problem together and then kind of discuss the approach for solving it, and then I'll implement my solution in Rust and kind of make grunty noises, and Sam will say more interesting things while I make grunty noises.
Yeah, see, Joey has interest in, Joey has interest in, what the problem is. I like the narrative that Advent of Code is kind of following, and I try to help integrate it into that.
All right,
Versus he
3,
likes to
2,
skip
1.
past that.
Okay, skip the flavor text. Skip to paragraph 3.
No. Okay. I'll
The
go
pocket
back.
dimension. Whoa, wait a minute.
Can we just read the whole thing?
Okay.
As your flight slowly drifts throughout the sky, the elves at the Mythical Information Bureau at the North Pole contact you. They'd like some help debugging a malfunctioning experimental energy source aboard one of their super secret imaging satellites.
The experimental energy source is based on cutting-edge technology, a set of Conway cubes contained in a pocket dimension. When you hear it's having problems, you can't help but agree to take a look. What's that?
The pocket dimension contains an infinite three-dimensional grid. At every integer three-dimensional coordinate xyz, there exists a single cube which is either active or inactive.
Every single cube, which is either active or inactive. In the initial state
I
of the
don't think
pocket
the fact
dimension,
that the cube matters.
almost all cubes start inactive. The only exception to this is a small flat region of cubes. The cubes in this region start with the specified active or inactive state.
Hashtag or dot.
The-
I would like 1 or 0, but that's just me.
The energy source then proceeds to boot up by executing 6 cycles. Each cube only ever considers its neighbors, any of the 26 other cubes, where any of their coordinates differ by at most 1. For example, given
This is
the
going to
cube
be
at
awesome.
1, 2, 3, its neighbors include the cube at 2, 2, 2, the cube of at 0, 2, 3, and so on.
So it's just each one has 6 neighbors, right?
Each one has 26 neighbors.
26 neighbors. Oh, so it's
3
every
cubes
single
minus
one,
1.
even the ones that are tangential.
Even the
Okay,
ones that
sorry.
just share a corner.
Yeah.
I think.
Okay, that's a lot of neighbors.
Um,
During a
I guess
cycle, all cubes simultaneously change their state according to the following rules. If a cube is active and exactly 2 or 3 of its neighbors are also active, the cube remains active. Otherwise, the cube becomes inactive. If a cube is inactive, but exactly 3 of its neighbors are active, the cube becomes active. Otherwise, the cube remains active.
inactive. The engineers
Yeah.
responsible for this experimental energy source would like you to simulate the pocket dimension and determine what the configuration of all cubes should be at the end of the 6-cycle boot process. Consider this state. Even though the pocket dimension is 3-dimensional, this initial state represents a small 2-dimensional slice of it. Simulating a few cycles from this initial state produces the following configurations, where the result of each cycle is shown layer by layer at each given z coordinate. And it walks through an example. So this is happening in 3D space.
Yeah. I like this problem already.
After the full 6-cycle boot process completes, 112 cubes are left in the active state. Starting with your given initial configuration, simulate 6 cycles. How many cubes are left in the active state after the 6th cycle? So this is, Sam, I don't know if you remember, but there was a problem earlier this month in Advent of Code. I don't remember which one.
If
but
I
with-
was not there, I probably did not attend. Other than
Oh,
to,
maybe
like,
you weren't there.
crack me.
13, 12. Let's see. I think it might have been day 11. Yeah, it was
Okay.
day 11. This seating system where seats become active, filled or unfilled, depending on their neighbors.
Yeah.
Whether they were filled or not. And that's like a cellular automata thing, and that's what we have here also, except it's in 3 dimensions.
Which is really fun to think about how they each relate to each other.
Mm-hmm. So, my approach for this, I think, is basically we start with the state, and then I go through and kind of compute what the next state should be from the previous state, and I do that 6 times. Basically,
Yeah.
I'm following the rules given here.
But so what's our input? Can we take a look at that?
Yeah, the input is basically a slice, like because we have this.
Oh,
plane.
so we're still doing 2-dimensional for this first
No.
problem.
Our input is a 2-dimensional slice. So all of the initial cubes are in one plane with each other, but the space that the problem takes place in is 3-dimensional.
Oh, okay. Oh, so whoa. And so how do we know the coordinates of this slice?
Well, it doesn't
'Cause
matter.
This looks like a line of them. Well, it would be different if it was a line versus if it was a square.
It's a square. We're
Oh,
given
it's
a plane.
square.
Do you see the output, the input on screen here?
Yeah, I'm looking at my own. I get 8 of them. Is that right?
Well, it's a square. Right. That
There's-
is a two-dimensional space. It's a two-dimensional.
But isn't there 8 lines there? Correct me if
Well,
I'm
sure,
wrong.
there's some number of lines, but I don't care. I don't
Then-
care how many lines there
And
are.
how does that form a square in 2-dimensional space? That's going to be a
8
rectangle.
rows and 8 columns.
Oh, so how are there? Oh, this represents 8 rows and 8 columns.
Yeah.
Oh, I was thinking of it as each one of those was one. Yeah, now yeah, that was silly. Okay.
Yeah,
I
because
interpreted
each
it.
cube is either active or inactive.
So we have an 8 by 8. It's like a chessboard.
Sure. Yeah. So I'm gonna start going on this. I think.
Yeah.
I'm gonna represent my state as with hash maps, because it's gonna sort of grow in an. Well.
Well, can we talk about it a little more?
Yeah. What else?
So so I think we're going to be paying attention to the hashtag one, so the pound sign, whatever you want to call it.
We have to pay attention to every square, because every square, based on the rules here, so the rules say if a cube is active and 2 or 3 of its neighbors are also active, it remains active. Otherwise, it becomes active. If it's inactive and exactly 3 of its neighbors are active, it becomes active. So we have to consider every single square.
Oh, yeah.
Every single.
We're gonna.
coordinate.
I guess we should have. We'll probably have 2 things because it's if this or that. It's like an or statement to begin with. Joey, I can't hear you. I've lost you.
I'm not talking. That's
Oh,
why.
I'm looking at your old self. Sorry.
Yep. How about can you approach this from the perspective of how you like how you would solve this? Because I have a pretty clear picture. I basically just have to translate what's said here into code.
Yeah.
Kind of the instructions.
But yeah, well, like
There's no
you need to
algorithms
go
yet.
a little more into specifics other than translate it into code.
Okay, so if a cube is active and exactly 2 or 3 of its neighbors are also active, I will mark that cube as active.
But how are
Otherwise,
you
I'll
going
mark
to
it
keep
as-
track of the new cubes that are, like the squares that are now becoming active outside of our 8 by 8 grid?
Right. So
Isn't that the question?
So I'm going to use a vec of vecs of vecs. A vec is like a list. Consider it like a row, and so I'll have like one row is like one dimensional, but then if I have a row containing a bunch of rows, like a list of rows, then that gets me 2 dimensions, and then I'll have those items within another list, and all of those that'll be the 3rd dimension.
Okay. Like, I guess I'm wondering how your computer is going to know when to stop computing, like when to stop questioning about the inactive.
Okay, that's a
squares
great
that are
question.
outside of our
That's a
8 by
great
8.
question. Basically, we have kind of a rectangular bounding box of kind of interesting state. So to begin with, we're given this rectangle, this plane, and we know that the only place that interesting things will happen is like in that plane that we're given, and basically in all of the neighbors, because everything else is
Yeah.
going to stay inactive.
Well,
So
the neighbors are going to, with each layer, it's going to get 1 dimension bigger, 1
Yep.
unit bigger
Yep.
in each direction.
Yep.
So are we going to essentially, like, are we going to say, hey, now we're computing for all of these
Exactly. So we'll grow in
with each step?
yeah, we'll grow basically grow 1 left, 1 right, 1 up, 1 down, 1 in and 1 out per cycle.
Okay, I see.
Yeah. So I'm gonna parse my input. This is gonna be quick, I promise.
See, yeah, me and William are on the same page, as well as Harry. We're all like, it's getting bigger, and you are as well.
Yeah.
But how it gets bigger, that's, I guess, what's interesting to me.
Yeah, so
'Cause
I mean,
computing it-
I will know how many rows and how many columns and how many, I don't know what you call a third dimensional column is, but I'll know how many of those I have, and I just need to and I can
Yeah.
assign them coordinates, and the coordinates can be arbitrary. So basically, for each range, I need to go. If we basically assume that I start at 0, 0, 0 and expand just in the positive direction, then I need to start at -1, -1, -1, and end at the maximum at the other end of that cube, kind of extended out by 1. If you sort of picture that.
Yeah. But so I imagine this is us doing it MythBuster style, because we might need to get more efficient.
I don't know about that. I guess we'll find out what.
Like,
what it
for all
is.
we know, it's going to be like, oh, do this 10 billion times, 10 billion cycles later, what does it look like?
Yeah, well, we'll find out. We'll get there.
So you don't have any predictions for step 2?
I don't for this problem. Do you?
I don't think they're going to change the rules of it. That doesn't seem to be, now that I've done a few of these.
Well, on
It's gonna-
on the last problem like this that had us do this in 2 dimensions, they did change the rules, so it's a possibility. I don't know, though. Oops. But you think that they won't change the rules?
That's my guess, is that it's going to be, it might be another one of those ones where, because I could imagine this getting really computationally challenging if you expanded it in any way.
Mm-hmm.
But maybe that's just too easy for them.
I'm just downloading my input. Oops. Wrong day. Cool. William's come up with a formula for
Yeah, I was
the
reading.
dimensions.
So is that the kind of thing you'd plug into your code?
Not quite. I'm just gonna basically each time I have an X width, like a Y length and a Z depth, and I'll just increase that each of those by 2.
Yeah.
Which is kind of what William is saying here with his formula. I won't be using a formula like that directly.
Because I guess the efficient way to do it, in terms of if somehow they wanted us to scale up, would be to only look at the 26 neighbors to each on box, because then we're looking at a smaller number overall.
Sorry,
Rather than
I zoned out.
we could increase our rectangular prism or our cube or whatever you want to call it each time, but in terms of the number of things you have to check, I imagine it would be computationally simpler to just check the 26 that are around an active cube each time.
I'm not sure how much time that would save us, because we still have to check every cube to see whether it's active. But that's a good thing to keep in the back pocket, because it might.
Because I imagine if you did this a billion times, you're going to end up with kind of arms reaching out. But it's not necessarily.
Yeah, that's a good point.
Yeah.
But you would have lots of other empty space. Yeah, maybe.
Yeah, you're going to have all this empty space, and hopefully this might be a way to, kind of get past that. Yeah, I think me and Joey already think what William is kind of saying, which is that it needs to get bigger one cycle at a time. I'm just saying it doesn't even need to get bigger it doesn't need to be a pretty shape each time that we're looking at. It might prove computationally simpler, especially at this scale, to just keep making a bigger bounding box. But at some point, I think it probably gets to the point where that's not the way to look at it. It would be interesting to decide what data structure would be nice to track a branching bounding box. I agree. I am not a computer person, as you may or may not know, William. So that would be interesting. Can't even theorize as to what would be good for that. Like, I'm happy I was able to get Zoom functional.
um,
Thank you, William. I'm proud of myself as well. But today was not a proud day, for reasons that I don't think I'm going to get into on today, but that Joey knows about.
I thought you did boat fixing.
I did fix the boat, but at the cost of some other things that we discussed.
So I'm kind of moving the origin in each iteration here because it makes things a little bit simpler, but I have to account for that because basically what starts out as 0, 0, when I expand my boundaries, ends up becoming 1, 1.
Oh, you wanted to move over?
Yeah, it's simpler that
That's
way.
kind of tacky, but yeah, I see what you mean.
But I have to account for that, and I want to make sure I'm doing this in the right way.
I would have kept the origin in the very center, even if that... But then I guess, like, I don't know.
The thing is, I'm working with positive indices, so in a sense, what I'm working with here is kind of like I can only do positive coordinates, and that ends up being fine for this, I think.
Oh.
Let's see.
But there would be. It's not like there isn't a way to do it negatively, right?
There's definitely a way. Yeah, for sure.
Yeah.
Joey's just a very positive guy. He likes to keep it upbeat, positive, happy. He'll even sing us some holiday music today for us.
Will I?
If we manage to, if this takes over an hour, you have to start singing Christmas carols.
Okay.
How's that?
Okay. Y row dot push is active of X, Y, Z and the old state. Sorry, I'm mumbling.
No worries. I'm sending some emojis to the group to
Oh,
keep
nice.
their spirits high. There's a lot of options here on YouTube for emojis. You can do a pig face, a pig with a body, or just a pig nose.
Oh,
Like who knew?
I can be smarter with my ranges here.
Why is that?
I was iterating between the range of like 0 and 8, well actually 0 and 7, and then, 0 and 9, and then subtracting 1 every time, but actually that's the same thing as just going from -1 to 8, if that makes sense.
Yeah. I thought we weren't doing anything with negative numbers.
Well, because I'm changing the origin, I'm kind of working with two separate coordinate systems at once.
You always have to move the origin in a negative direction. Down.
Well, I'm moving the origin in
And
a
X, Y,
positive
Z.
direction, but then I have to translate the new origin into the old coordinates, and that ends up being at like -1, -1, -1. If you
I
did.
think you lost me there. I don't think.
Okay. That's
Maybe
okay.
that was a clear explanation, but maybe it wasn't.
No, not really. At least not without visualization on my part. And I'm
Because from what I understand is like you have the current origin,
And relative to that, the next one is always going to be at -1, -1, -1.
Relative to that, the next one is going to be at +1, +1, positive.
Relative to the most
Oh,
recent
yeah, yes.
version.
Yeah, what you said is correct. Sorry. Yeah.
Yeah, as you advance, it's always moving further left if we want to think left, right, positive,
Mm-hmm.
negative. Like kind of the traditional.
Oh, I missed some messages.
So now
So
I
my
have to-
question, Harry, is what brings you to the stream so early every day? Like, are you waiting those 36 minutes till it starts? Or who knows? Inquiring minds want to know. What is a mutt?
What?
What is a code encoding? What is a mutt in Rust?
Mute it means that something is mutable. You can change it. In
Have they
contrast
thought
with
about
immutable.
adding E to the word mute?
No, it's short for mutable. M-U-T-A-B-L-E.
But you don't want to type that much because hacker's gonna hack. Am I right?
Sure.
Syntax error detected. Angry laughing emoji.
What? There was no syntax error. I'm having type stuff. No
Told
syntax
you I
error.
saw a syntax error.
Yeah, there's no syntax errors right now. Sometimes there are.
Prize
These are
based
type
emoji.
system errors. This is gross. As I32. As I32. No, so syntax is about how you, basically what the tokens in a programming language mean. So like, a function starts with a curly brace and closes with a curly brace, and statements end in
So would
semicolons
you say
and so
that
on.
this is a syntax error?
No, so this isn't
Error
about
in the
syntax.
ability to
Syntax error would be
identify
if I wrote something that
syntax?
just doesn't make sense, like doesn't follow those rules. Like I opened parentheses and then didn't close them. The
I think
type
we're
system
being
is at a
technical.
level higher above syntax. Your syntax has to parse successfully before you can kind of evaluate what the type system's like. I'm saying this more to Harry than to you, Sam.
Yeah, I know. But I'm just saying I think we have a heckler here. But we're gonna beat Harry, right?
It's not competitive for me.
The thing is, Harry could also just steal all our code.
Oh, Harry meant my 4x:I32 in something. That was a syntax error. Okay, fair.
So there was a syntax error the whole time? After all this heckling and counter heckling?
Yeah, with the stream delay, I guess I didn't see it for what it was, you know? Okay, so,
Oh man, I stood up for you, Joey.
x in, for dx, no, yes, for dx in -1, 0, 1, for dy in -1, 0, 1, for dz in -1, 0, 1. I'm just getting all the adjacent cubes. If dx, if they're all 0, then we're like looking at ourselves, so we want to continue. And if they're outside of the bounds, so if dx is less than 0, or dy is less than 0, or dz is less than 0. That means they're out of bounds, so again we want to kind of continue and skip this iteration. And then if they're out of bounds in the other direction, in the positive direction, then we also want to continue. So x width is state.len, y width is state.first.unwrap.len, and z width is state.first.unwrap.first.unwrap.len. Cool. So then if, oh sorry, this is not if dx is, so then actually, sorry, x is,
Ooh, we have a fourth person in the chat. I mean, not in the chat, in the watching, meaning that we have 2 actual attendees doing this. Very high stakes.
Awesome. So we find out our coordinates, and then if those coordinates are negative, we continue, and if those coordinates are too big, then again we continue, and finally I can do my actual processing. So I want to count the number of cubes next to me that are active. So that starts at 0, and then, oh, I don't need to do this index nonsense, I think, because I can just get items and check if they're none or some. Okay. Changing up the code here, Sam. Some good changes.
Are we gaining efficiency?
Yeah, let's say that. We're not actually. I'm just making it be coded better.
That seems kind of wasteful then.
I think it'll make it harder to have a bug. I like the cheese and mouse emoji you have there, Sam.
Well, they match, you know? You can't have one without the other. It's just like, what is it, like a cold December night without advent of code. But there are 6 of those, if I'm not mistaken, each year.
Okay, wait, so there we get a row. There we get another row. This is an element, though. So then, if that element is true, then we increment our count. So then, now that I've finally counted the number of active cubes next to my current cube, then I return, so, oh, I need my cube's current state. Okay, let current state
Would you say that the current state is measured in amps or milliamps?
Milliamps, probably.
Okay.
So if I'm active, I am active. Okay, if I'm active, then we follow one rule. So then, if our neighbors have to be exactly 2 or 3 to be for us to stay active.
Yeah.
But if we're not active, if we're inactive, our neighbors have to be exactly 3 active.
I just can't see them not asking us to scale this at some crazy level.
Yeah?
Because there's so much like inefficiency in our methods right now.
Is there?
I think so. Given my like vague understanding of it.
So yeah, I mean, we have to process every element once, like in our whole in our like 3-dimensional array. But I'm not sure that I know of a sort of a faster algorithm.
Well, I like as I was saying, you should be creating like you can essentially create a cube, like a 3 by 3 by 3 around each cube, each single active cube going into the next round, and that's going to have you looking at.
To know which cubes are active, I have to still go to every cube.
Don't you have a list from the last one? Like when you're trying to figure out what's happening in this, like when you're trying to iterate, I guess I'm saying, like so, so right now, starting with our base information, imagine just in 2D, just to think about it, you put a square around each of them. Right now, that's not gaining us much efficiency, if any. It would gain us like 1 or 2 squares, maybe. But as you grow up and it expands, there's going to be squares that you don't have to look at now. And you always know from when you last computed which ones are inactive. I mean, which ones are active. So you generate the list of the active ones, and then you say, the one that's right above, check that one. The one that's right below, check that one. Like you would list all of the squares that are like valent squares, I'm calling them, all the ones on the perimeter. And then only if that one comes up 3 times does it become active, right? So you gain 26 numbers from each active square, and you check through your list to see if that set of coordinates comes up 3 times. If it does, it's active. If it doesn't, it's inactive. And then you do something similar for the active ones. William says Sam's right.
That's good. I'm glad. I trust William.
I really like you, William.
Joey, imagine one layer of a breadth-first search from
Oh yeah, I don't think that's our
active
game
square.
plan either. But if we have to do like
Wait,
6
let me think
million
about
iterations,
Yeah. I'm not sure that I think it would be faster in real time, but I'm not sure how much it would improve algorithmic time complexity. And if it doesn't improve algorithmic time complexity, then the real time difference is small. This is me mostly talking to
number
William.
of times the NAND gates have to fire.
Yeah, the NAND gates.
And as we know, there's like trillions of NAND gates.
William, do you know of what's it called? NAND game?
NAND game is lit.
Sam's been playing it.
I'm not that far along actually, but soon I'll have a computer. Elizabeth Lee, how are you doing this fine evening? Yes, it does. You start with the simplest gate, which I believe is a NAND gate, and you have to build up gates and kind of assemblies up until you're able to create a CPU and a RAM and everything that you need to make an entire computer. And it's all just with kind of
What do you call that type of logic? Not Bosnian logic.
Boolean.
Boolean logic.
But it's more than Boolean logic because you build flip-flops and stuff. So you end up involving state.
Boolean logic?
No, not really. Like it. William says, "Wow, that sounds like a course I took."
I think you guys took that course together, right, Dewey? No?
Yeah, we did.
Yeah. I'm taking a course, and I'm learning about transistors and silicon. So I'm in your boat. But I still don't really understand what a transistor, like how to make a transistor do what I want. I should make an amplifier or something to kind of figure it out.
It would be cool if you made an amplifier.
Elizabeth Lee is doing statistically well, which is good. William thinks that I could figure out transistors. I hope so. I have some in my car that I should take out. Like, not like as part of my car, they are like currently being stored in my car. And I'm excited to try them out. I think she's doing statistically well at statistics, meaning that she's in the top of the bell curve of her fellow students.
I have a program that runs, Sam.
Exciting.
I don't know if it works. I'm gonna try the sample input first.
Does it work?
It definitely doesn't twerk. Uh-oh, it panicked.
How long
Line
would that
59.
make a working program? So,
Oh, no.
come 10 o'clock, Joey's going to be singing some Christmas carols for us. Just for the
Get. I suspect Elizabeth Lee is doing statistically well at statistics homework. That's my guess.
Yeah. Am I playing something on my laptop? Yes. Yeah, I only bought 4 transistors at the transistor store, but that should prove enough for my simple class and breadboarding and such. I'm gonna study for this statistics final. That's what Elizabeth Lee would say.
Is it?
Is
Doesn't sound
statistics
like her.
harder than it was in high school, Elizabeth? Or is it just review of all your high school work? I imagine it's the latter, right? Like Mr. Becker is teaching top level stat. Doesn't get any more complicated than that.
I wonder how Harry's solution is coming along.
Harry has left the chat. I think he's either focusing or mad because I called him a heckler. Which of those things we'll see. Oh, Elizabeth Lee didn't do statistics in high school. Whoa.
Well, but you had Stalk, didn't you?
Oh, because BC had some stat in it?
It did.
Right.
At least when I took it, the year that I took it.
My name's Joey, and I took BC Calc before everyone.
Well, not before the other people in my class.
Wow. My name's Joey, and technically right is better than being actually right, you know?
Accurate, I think, maybe. Okay, let's try it with the sample input again. We got the answer 0, which is not correct.
How do we know? Is this a sample input?
Yeah.
Yeah. 112 cubes.
Okay. What do we do from here?
Yeah, print your immediate slices.
Yeah, I think
Brilliant.
we're gonna print our intermediate slices. It's a great idea. It's just annoying to print stuff out in Rust because it doesn't. Oh wait, Harry told me about the debug macro. We'll try that. So. Okay, that prints it out in not pretty, but it works. Okay, so initially our state is we have false, true, false, 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 true, 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 true. Then, at our first Z level, we have you don't need the format string, says Harry. Well, I'll be damned.
And then I called you a noob.
Such a noob.
Yeah. Is noob spelled N-E-W-B, like newbie?
No. N-O-O-B.
Noob like boob.
False, 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 false. False, 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 false. It's all false. It's all false. It's all false. So that's not right. So after my first iteration, everything is ending up as false. Let's see. So next state, we push the result of calling is active.
That's a stretch, Elizabeth Lee, but I'll take it.
Here, each state equals the next state. Okay, so is active. We have that active count. Let's print the active count. Let's not print our state. Oh, this is a really cool macro. So we're getting active count 0 always, and that's not right, because we should be getting
Yes.
some points where okay, so let's print X. I'm loving this macro, by the way, so thank you. I don't know why I didn't use this sooner. Let's print out Z. Print out the Z element. There are print statements, but it's like printf. You have to kind of provide specific formatting. This macro seems to do some sort of, no, I totally have access to standard out, but this macro seems to do some sort of kind of magic. It'll print it looks like it's printing the expression and the expression's value and a line number, which is super helpful here. So I'm getting element. So the element at, for instance, 0, 0, 1 should be true. Let's see. So do I get? I want 0, 0, 1. X is 0, Y is 0, Z is 1. ZLM is true. And then, yeah, so ZLM is true here. And yet somehow oh my god. Check this out, Sam. Look at my code. Line 59. I think even you might notice this mistake. Well, first on line 40, I say active count equals 0. And then, when I find the thing that I'm looking for, that I'm trying to count, I say active count plus equals 0, which means add 0 to the value of active count. Do you see how starting with 0 and then adding 0 every time is not going to get me the count of the things that I'm looking for?
Just maybe.
Turns out that I have 0 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0 items. That's cool.
So we were taking guesses for my head circumference. Elizabeth Lee guesses 26 inches. You can guess in metric or imperial.
And it turns out, Sam, that once I fix that stupid bug, I get the right answer for the sample input. So I'm going to try it on the real input. I have no guess for your head circumference, by the way.
William's guess is in decimals of a nautical mile.
That's nice. That's cool.
Oh, he guesses 19.97 inches.
All right, 47 minutes in, my answer was 380. That was correct. On my private leaderboard, oh my god, I've been beaten to the punch because the other guy has gotten part 1 and part 2 done already.
Oh my gosh. Maybe part 2 is easier than
let's
one
see.
man.
Oh my god, it actually has 4 dimensions, not 3.
Fuck.
Okay, so instead of XYZ, it's XYZW.
Which exponentially increases the...
But it should be fine if we don't have to do it too many times. Let's see. We consider its neighbors. There are now 80 neighbors. I can just update my code.
81 minus 1.
Exactly. Furthermore, okay, how many cycles do I have to do? I really don't have to adapt this very much at all. 6 cycles! Sam, this is a walk in the park. They didn't make it any harder.
No wonder your competition got both in. Well, Joey might not be singing Christmas carols for us today.
I don't know that I'm going to be done by 10, but that would be really super cool if I was. Let's try. We'll try for it, Sam.
Yeah, I agree with William.
What did William say?
That your current code should be pretty easily adaptable.
Right, I just have to add 1 extra loop here or there. And another layer of indirection.
I wanted to clarify William's guess. I was hoping that we could get a guess of my head size from Harry, because I imagine Harry operates in the metric system. But if not, I'll announce it when the clock strikes.
Oh, have you actually measured it?
51, yeah. I have this flexible tape measure.
So I'll just wrap it on the outermost level. We have X. The problem officially says X, Y, Z, W, but I'm going to do W, X, Y, Z. Actually, no, I'm gonna do X, Y, Z, W. That's actually the right way to do it here. Okay, so W unwrap dot first dot unwrap is active 2 X Y Z W okay, now I need to define the function isActive2, which just comes from my original isActive function. I'm just duplicating my code all over the place here. It's great, it's beautiful, we love it.
So, just an interesting tidbit is once you are looking at the actual resolution of the measurement, William and Elizabeth were pretty much equally far off in their guesses. So I think it's a tie. Because it was 23 inches plus or minus an eighth of an inch, just due to the logistics of using this tape measure. And so Elizabeth Lee was 3 above, and William was 3.03-ish above. Or below.
Nice. That's pretty cool.
It proves that statistical theorem that if you have enough people guess the number of beans in a bottle, you'll get a pretty good answer. If you take the average, or if you take I don't know if it's supposed to be you take the average or if you take
You're talking about the wisdom of the crowd?
Yeah.
That sort of thing?
Exactly. So this is the wisdom of the crowd, but with 2 people, and it was actually really accurate.
Okay, dx, dy, dz, and then I need dw.
No, Elizabeth's guess was 26 inches. If you scroll up in the chat, William. So it was pretty perfect.
Let W.
Somebody disliked our video.
Really?
Yeah.
Really?
Oh, but then I disliked it, and then someone disliked it, and then I thumbs it up, and someone thumbs it up.
Maybe it's just you.
Why is it saying 2 thumbs up right now?
I'm not looking at that.
The person keeps chasing me.
I think it's you.
Now there's 3 thumbs up.
Nice. Harry just finished. Didn't we have a question for Harry? I forget what it was though. I'm busy working here on part 2.
Oh, Harry. Harry can see the answer. The question was my head diameter or circumference. My head does not have a diameter.
I need an extra. Okay, if 0 is that, we continue. W element is 0 dot get. W is U size. If W element active count plus equals 1. Okay, that matches that. That matches that. This 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 matches that. Why can't it parse that? Ugh, what did I do? Do I have an extra? Cannot parse. Not file. Extra bracket maybe? Contains an unclosed delimiter. I'm just not matching my brackets right. Apparently.
Syntax error, am I right?
Yeah, it is. It is a syntax error.
So I typed in your symptoms into the computer, and it says that you may be having network connectivity problems, Joey.
Thank you, Andy. Oh, what's going on? Okay, comment out some random functions here. Comment this one out. Oops.
The ghoul on the stool. Is this a version of the elf on the shelf? I've never heard of the ghoul on the stool.
Out.
Ghoul on.
Comment that out.
Oh, whoa.
What is... Comment this out. I'm just having... Oh, that was the issue. So let's uncomment everything else.
According to the Ghoul on the Stool Facebook page, Ghoul on the Stool is Halloween's #1 family tradition.
Vec. Oh! Is this why Elizabeth was saying get? Because I have a whole bunch of vec. If so, that's amazing.
That was very smart of you, Elizabeth Lee, if that's what you were intending. If that's what the intent was.
Why can't it parse this? Literally, what is wrong with my code here?
Hacker's gonna hack, that's all I gotta say. Maybe we've been hacked.
What the hell? Let's try cargo build.
Adios, Elizabeth Lee. We're almost done, and Joey's gonna be singing songs.
Oh,
in
why is this?
3 minutes.
Oh. Oh, I just needed a 4th closing caret here. And that caused the whole file to be unparsable. Okay.
Did you know that William lives in a surveillance state?
Let's just try running it on part 2. I did not know that. And hope that it's right.
Yeah, there's a boulder on his shoulder, an elf on his shelf, and a ghoul on his stool.
X, Y, Z, W, line 69.
Elizabeth, it's only if he fails to meet the requirement of 10 p.m. that he'll be singing until he solves the problem. So
Oh, I have to sing until I solve the problem? That's double.
Yeah. Don't you think that's only fair, Joey? You're so close anyways.
Ooh, for computing my answer, I gotta go 1 level deeper. Iter dot map cube cube dot iter dot map blah 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 dot flatten. I'm racing the clock here. 170. Let's go, come on. Oh, I gotta go even further. Shit. I mean, crap. Am I family friendly?
I don't know, I got called out for saying the B word and it wasn't even
Frosty the snowman had a very frosty nose and a corncob pipe and a button pipe and 2 eyes made out of pipes. Corncob the pipey was a very pipey man. He went to school and paid his spool, and he went back to the band. He must have been a farmer, 'cause he said, let's get some carrots. And then he fed them to his horse, and they learned about ferrets. Hey! Frosty the Snowman was going to the school. He ran his code, and it was correct, and he didn't have to sing no more. Hooray! I solved it.
You gotta. It's till you submit it, right?
Yeah, no, I solved and submitted it.
Okay. Good deal. So you submit it using your computer, using like, is that Terminal?
I wrote a little program, a little Python script that fetches my input and submits my answers.
That's
I
pretty.
guess. William stuck around for singing, and it's 1 a.m. over there.
Wow. We appreciate.
Thank you
your
also,
time.
Elizabeth Lee, for sticking around for singing. This has been short and sweet. I think we did it in an hour, Sam Dubois. I think
But
we end the
don't
stream here.
sign off yet because I'm trying to thumbs up and it's stuck on the thumbs down.
You can
for my-
thumbs up the VOD after the fact, or try refreshing the page. Got any parting words, Sam?
I don't know. We have 2 thumbs downs, 2 thumbs up. I think that's a metaphor for how today went.
Perfect words to sum it up. I'll be streaming again tomorrow.
Goodbye. Adios. Hasta
Bye-bye.
pronto.